Welcome back, everyone. So we are now going to spend a little bit of time introducing one common discrete probability distribution function. And so we're actually going to skip over this binomial part and jump straight into the geometric probability distribution. So, before we actually get to the probability distribution function itself, we're going to try to build up a little bit of intuition here with what this distribution really is. And so we're going to use this example from the Pokemon video games. And so, in the earlier games of Pokemon, you could encounter what was called a shiny Pokemon. And so these encounters were rare. And in fact, the game developers say that only one out of 8,192 Pokemon encounters are encounters with shiny Pokemon. For those not into Pokemon, shiny Pokemon are like really not that special or anything, but some people really like them and think they're really cool. And so, again, before we actually get to the formal definition of this, we'll answer a couple questions. So what's the probability that a gamer encounters a shiny Pokemon on their very first wild Pokemon encounter? And so this is the probability of a success on the first try. And so we're going to abbreviate that as the probability of S1. So S for success, 1 for the first encounter. And that information is just given in the problem. And so that is equal to P, which is 1,000, or 1 over 1,000, or 1 over 8,192. The next question asks, what's the probability that the gamer finds their first shiny Pokemon in their third wild Pokemon encounter? And so a couple keys here are that it's their first shiny Pokemon, meaning that they have, so success on third try. And again, this is the probability that their first success comes on the third try. What that means is that they have failed in their first wild Pokemon encounter. They've also failed in their second one. And they did find a shiny Pokemon on their third encounter. One key with this particular distribution is that we assume that the trials are independent. And so that lets us rewrite this probability like that. And so if we assume that the trials are independent, then we have this quantity. And so the probability of not encountering a shiny Pokemon on the first trial is 1 minus P, where P is 1 over 8,192. The probability of failing on the second trial is also 1 minus P. And the probability of success on the third trial is P. And so I'm just going to rewrite that and then plug in my value for P, but I'm not actually going to calculate this out. It would be some really, really tiny number because 1 over 8,192 is a really tiny number. Okay, so now translating some of this into a formal definition of what a geometric random variable is, I'll try to highlight some of the pieces that we talked about. And so we had the same probability of success on each trial. So that is an assumption that we have to make here. The trials, we said, are independent. So that's another assumption. And then we're defining y as the number of failures before the first success. And so in our example, y would be the number of wild Pokemon that we encounter that are not a shiny Pokemon before we actually find that shiny Pokemon. And there's a small typo here where this p is 1 over 8,192. And so now let's use this probability distribution function to answer the same questions or similar questions to what we answered on the previous page. So using this geometric probability distribution function, we could find the probability that the gamer finds a shiny Pokemon in their first wild Pokemon encounter. And so remember the way that this is defined, it's defined as the number of failures before the first success. And so we just have to be a little careful that we're not looking for the probability that y is equal to 1. We're looking for the probability that y is equal to 0, because if we get a success on the first try, that means we have 0 failures. And so then you could just plug in 0 to the formula up above. So 1 minus that raised to the 0th power, so that drops out, because anything raised to the 0 power is equal to 1, and we're left with the same answer that we had before. This next last little problem says what's the probability that it takes fewer than 3 attempts. And so again, the trickiest part of this is that we have to be careful with the wording. Fewer than 3 attempts means that our y has to be less than 2. Because fewer than 3 attempts means that there has to be fewer than 2 failures before the third attempt is a success. And so we could rewrite that as the probability that y is equal to 0 plus the probability that y is equal to 1. And again, from there we could just plug in 0 and 1 into the formula. Okay, so again, I won't actually calculate this out, but I will throw the numbers in here. And we will primarily use R to actually calculate these. And so for the first one, in R, we can make use of this dgeom function, which takes the first value as being the y that you're interested in. The second value is the probability parameter in the geometric model. And then to figure out this second one, we can make use of the pgeom function. And again, the first value is is 1 because we want the probability that y is less than or equal to 1. And then the second value is still the probability that you are interested in. And so if you throw that into R, you should wind up with, again, some really tiny probability because of how rare shiny Pokemon are of 0.000244.